Bonjour à tous, bienvenue au webinaire consacré à l'énergie éolienne aéroportée et aux opportunités que ça pourrait représenter pour les filières du pôle, que ce soit dans la partie aéronautique, espace ou drone. Donc je tenais à remercier tous les intervenants aujourd'hui, qui sont nombreux, et je vous présenterai tout à l'heure les personnes qui vont présenter aujourd'hui. Pardon, j'ai affiché trop vite. Ce webinaire, en fait, pour vous rappeler un petit peu le contexte de l'organisation de ce type de webinaire sur des filières autres que les marchés habituels du pôle, on travaille depuis plusieurs mois, voire plusieurs années maintenant, sur les aspects de diversification du pôle. Ça s'est intensifié ces derniers temps. Et donc, on a mis en place une collaboration avec l'agence ADOC, donc l'agence régionale d'innovation de la région Occitanie, sur des sujets éoliens au sens large, donc éolien offshore flottant en particulier. Et dans ce cadre, nous avons rencontré Christian, Yudo et Stéphanie et les d'autres intervenants que vous allez voir cet après-midi autour de tout ce qui concerne l'Airborne Wind Energy. Donc on souhaitait un peu vous présenter de quoi il retournait aujourd'hui et puis de voir quelles opportunités, quels partenariats, que ce soit innovation ou industriel, pouvait être mis en place entre les acteurs du pôle que vous représentez et les acteurs de l'Airborne Wind Energy. Donc, je ne vais pas être beaucoup plus longue. Je vais laisser Julien Siglard d'ADOC se présenter pour que vous puissiez un peu prendre connaissance des actions qui sont menées par l'agence ADOC sur le sujet.
Bien, bonjour à tous. Merci beaucoup, Émilie, pour l'organisation de ce webinaire. Et donc, effectivement, c'est une action qui est très importante pour la région, pour Airospace Valley, mais également pour ADOC, puisqu'il y a une croyance très, très forte dans le développement de cette technologie. Peut-être je vais passer en anglais, parce que le message s'adressera également à nos intervenants aujourd'hui. So yeah, we'll switch in English. So we are very glad actually to be part of this webinar today. We have been working for a while already with Airospace Valley on this subject, but as well with Airborne Wind Europe. I guess it's more than 2 years that we have been working together and discussing a lot about the development of this technology. Just to let you know, the region of Occitanie is very, very interested in the development of this technology, and there is really a strong ambition to take part in the development of this technology, which is the airborne wind. Definitely, we see this technology as a kind of a crossway with maritime, renewable, and aeronautic. And that's why we feel that over the entire territory in Occitanie, there is a lot of expertise and experiences that could be used for developing, testing, and promoting this technology. Definitely with Airospace Valley, we will be happy to support and help with any, I would say, collective projects on this topic. Once again, we will be very much happy to facilitate the development of this technology by ever means that you might need. So that's all for me, and I'll give you back the floor, Emily.
Thank you. Je reprends la main. Donc, au programme de ce webinaire, on va commencer par une présentation de Christian sur l'Airborne Wind Energy. Donc, il va y avoir 2 parties. Vous verrez une première partie et une seconde partie pour clôturer ce webinaire. Puis des présentations d'industriels qui développent des projets. Donc, avec Fabrizio Nastri d'Ampix Power, Thomas Carclot de Kite Mile et Tobias Brunning de Scale Sales Power. Vous pourrez poser vos questions tout au long du webinaire en utilisant l'onglet questions. Donc, n'hésitez pas à poser vos questions. On gardera en fin de webinaire un temps d'échange avec les participants. Donc, je lirai vos questions à ce moment-là. On verra si on peut ouvrir les micros, si on a des questions un peu et des échanges un petit peu plus complets à mener. Donc, voilà, n'hésitez pas à poser ces questions et j'espère que vous pourrez prendre connaissance donc, de ces nouveaux moyens de génération d'énergie et que ce sera profitable pour vous et que ce n'est qu'une première étape dans une future collaboration avec les acteurs de cette filière. So I'm going to give the floor to Christian.
Merci Émilie, merci et bonjour à tous. Et moi aussi je vais parler en anglais, mais si vous avez des questions en français, on va essayer de répondre. So yeah, thanks again for having the time and or coming to watch this webinar. Sorry, the slides coming up and down. I have to. The weird thing is that now I can't see the slides. Okay, now it should work. So I will give a short introduction about airborne wind energy. About the principles, the concepts, the advantages, and the markets, and then we have the three interventions, as Emily already mentioned, and then I will come back again to talk about briefly about the opportunities for collaboration. So we from Airborne Wind Europe, we are the member or the sector association. You see there our members. We are a member of Wind Europe and also have collaboration with other networks that you see there. So we are trying to be really visible and show that this new technology, this new renewable technology is well connected, not only in Europe, but also globally. So the general principle of airborne wind energy is that we capture wind at higher altitudes through the concept of kites or small aircraft on a tether. And here you see the different possibilities of how these kites could look like. So there are rigid or fixed wing kites that more look like planes, but you also have the ones that are more like big kite surfing kites, so to speak, soft kites, and something in between as well. So these are here the different members of our network. The general principle that most of the companies are doing is the so-called ground generation principle, where the kite flies out in circles or figures of 8, and the tether rolls out over a winch, and then you have a generator that produces the electricity on the ground. And once the tether is completely rolled out or reeled out, then the kite has to fly back to the starting position and starts the cycle again. So that's the yo-yo principle. And then there's also the so-called fly gen, where the electricity is produced with small generators within the aircraft, and the electricity is then evacuated through the tether to the ground and then connected to the grid or to the load. So the general idea is to emulate basically the tips of a conventional wind turbine, and by that reducing the weight and all the mass that is needed for the tower and the blades, and just capture basically the wind with a part of the wings that are the most powerful, also with the conventional wind at the conventional wind turbine. So the advantages are, from what I just said, really the one big advantage is that we have a lot lower need for materials for the tower, for the foundation, and all these this weight that's only not only material and weight, but it's also capex. So we reduce costs in the long term or mid and long term, what we hope to see there. By having less material, so that we can have very competitive costs for power generation. Another big advantage is that we come to a higher altitude, so we fly up to 500 or 600 meters, and the best wind in that range between 100 and 500 or 600 meters, this is where we can fly and capture this wind resource. So here you can see on the right-hand side map that the overall resource potential across Europe grows significantly if you can capture this wind in higher altitudes. So basically all across Europe you have excellent wind conditions for airborne wind energy technology. With that comes also a higher capacity factor, which means that we produce more energy during the time the system flies. which will help also baseload applications and just add another good technology for the energy mix and for the integration of renewables into the grid. As I said, we plan, or we think that we will be able to be competitive to conventional wind within the next years and then even undercut these costs in the future. This is also how here E.ON, now RWE, has presented that at a conference a few years ago. We are now already competitive with diesel generation, and we think we will be below the 15 cents very soon per kilowatt hour, and even less than in the years to come. So yeah, less material, additional wind resource, high capacity factor, low costs, and then the easy logistics and scalability will help us to grow into new markets like the repowering market, floating offshore, off-grid islands, and so on. And briefly on the markets, here you see some pictures of how this could look like. Floating offshore, where again we also would need less material, or combination with solar fields in mines or on islands. Floating offshore is actually one of the fields where most of the companies plan to go at one stage. We are not there yet, but one company has tried that in a very early stage of development and has shown that it is possible, but yeah, there's still a way to go to get to commercial systems in offshore conditions. But as I said, on islands, the systems are already competitive, or the ones at least that are commercialized, and we will hear more from SkySails in a moment. SkySails may also briefly talk about the spillover effects using kites for shipping, both for pulling the ships, but also for power generation on the ships. So yeah, the current state of the industry is that we have shown the proof of concept. Various or most of the companies have done that. Automatic operation is possible during day, during night, or during several hours over days. And now this year, actually, the first commercial systems come into operation. And yeah, we will hear about that in a moment. Just to show you that most of the airborne wind activities are taking place in Europe. We are a global industry, but Europe has an advantage at the moment, and we hope that we can build on that and make this really a strong European technology as well. We are being funded through public funding, like a Horizon project or this Interreg Northwest Europe project that's is partly paying our salaries at Airborne Wind Europe. But also national institutions are funding airborne wind, and there's also a lot of money coming from private companies or funders. Here you see a little bit the different companies or organizations, like including ADOC in this project that I just mentioned, this Mega project. RWE, and you see there on the right side also some aviation companies like Sapcar and Stellar Space Industries. So we have already contacts to your sector, but we think there are really a lot of opportunities to collaborate closer in the future. But before we come to that, I would like to hand over now to the three interveners from Ampex, Kitemo, and SkySails, and we start with Fabrizio from Ampex Power. So
yes, thank you very much, Christian. Hello, everyone. Let me try to share my screen.
I don't know if I have to do something now.
I don't think I can. Yes, now I can.
Ah, okay, good.
Okay, I'm sharing a screen, but I don't know which one. Can you see my presentation?
Yeah.
Yes. Yes.
Okay, great. So I need to move this. Okay, so hello everyone. I'm Fabrizio Nastri. I'm the CEO of Ampex Power. Ampex Power is one of the key players in the airborne wind energy sector. Just a few words about our company. We were founded in 2009. Our headquarters is in The Hague. We have about 60 employees today from 25 different nationalities. And so over the last 12 years, we've raised or secured about 52 million euros of investments, half of it in the form of equity from private investors, and the other half from subsidies, including the Interreg that was mentioned just before, and also partner contributions. So some of our industrial partners have invested significantly into the development of our technology in joint collaboration agreements. So far, we've already gone through 4 successive generations of prototypes. So starting with the smaller system, then progressively growing larger and larger. Now we are a 150 kilowatt system, which is our latest prototype. And we are collaborating with about 40 different technology partners. So suppliers, including suppliers from the aerospace industry, SAPCA and Stellar Industries were mentioned, but many others are working with us, universities, and also some large utility companies. We have a partnership with RWE. In terms of the technology, it's basically a pumping system. So ground-based power generation, rigid wing aircraft. And what's interesting is that we use horizontal takeoff and landing. So let me see if I can get this video. So that's an overview of our system. It's a 3D animation, but we will see this fly later this year in Ireland. So this plane that you see in this animation is a 150 kilowatt system. It's the one that you saw in the picture on the first slide. It's already built, and we are now doing some taxi testing in the airport in Breda. We will be flying in Spain later this summer, and then later this year we will be starting power generation. So this is a 150 kilowatt system. I'm not going to go through the benefits of airborne wind energy because I think that's been covered already. I will just maybe say a few words about what is specific about Ampix Power. So what's unique is that we are basically using a combination of rigid wing aircraft, horizontal takeoff and landing. So that means that there's no, on board the aircraft, there's only a very small propulsion system that provides some assistance during the takeoff, but then we use the lift of the aircraft and the wind to actually operate once we are in the power generation pattern and the power generation is on the ground. So this technological choice allows our technology to be scalable to multi-megawatt scale. And having a horizontal takeoff and landing is also a very safe and very robust approach. That's what we've been using for over 100 years. So we've done about 500 flights with our earlier system, AP2, and we've never had any crash. So it's a very robust system. And as we use rigid wing aircraft made in carbon fiber, it's also very robust, very low maintenance. So we are developing our system to airspace aviation safety standards. We're working with the European Aviation Safety Agency and the national aviation safety agencies. We're developing our technology to be certified and following very stringent technology development standards. So the target markets, like Christian mentioned, are the following. So we have what we call remote markets, islands, mini grids, and so on. And the value proposition is that we can replace diesel or heavy fuel oil consumption. Typically, we're competing with systems that are around 1 megawatt. And these systems today have very high cost of electricity, between 200 and 400 euros per megawatt hour for heavy fuel oil and diesel. So if we enter the market at 150, we will be competitive from day one. So that's our target. This is our first target market. as we develop bigger system, and we go into multi-megawatt, we will be aiming to compete in the utility scale wind sector, starting with onshore wind, and later going bigger and going offshore. So, I mean, you probably know the long-term projections for wind. Overall, we expect 250 gigawatts per year. The whole overall wind market, about 200 gigawatts per year onshore and about 50 gigawatts per year offshore by 2040. So our target is to capture 2% of that market by 2040. So it's about 5 gigawatts. How do we plan to get there? By building successively larger systems. So we've already been flying AP2 for quite some time. AP3 is a 150 kilowatt system, so it's a 12-meter wingspan aircraft. We've completed the assembly, and we will be starting flight testing later this year. Once these tests are successful, we will start manufacturing AP3 on a small scale. We plan to do a few dozens of these systems in order to deploy them globally in small demonstration projects. But the real deal will come with AP4, which is going to be a 1 megawatt system with a 25-meter wingspan. And we plan to progressively move to 3 megawatt and then 5 megawatts. And once we are at the 5 megawatt scale with a 15-meter wingspan aircraft, we will be competitive offshore. So going offshore requires, of course, that we reach much higher, bigger size, but also there's a lot of additional complexity coming to with working offshore. But we have a huge advantage compared to traditional wind when it comes to going offshore, is that not only do we significantly save on the mass of the system, we also save a lot on the mass of the floater, because the system is lighter. That's the first thing, but also because there's no torque. So there's much lower need for ballast. So at the end of the day, the floater are actually significantly smaller. So
Fabrizio, can you come to the end slowly, please?
Yeah, I'm coming to the end. So the cost reduction plan is to basically reach 16 euros per megawatt hour by 2040 by a combination of scale increase and technology improvements. Going offshore would double the cost, but we can also make some savings by having a bigger system and capturing a high wind speed. So we target about 25 euros per megawatt hour offshore. So that means we would be more competitive than traditional wind, both onshore and offshore by sometime around 2035. Yeah. So in terms of number of units per year, this would be, as was said before, in the range of 2,000 units per year. So we're talking about volumes that are significant also by airspace industry standards. I had some KPIs that I wanted to share with you, but I think we can send these presentations out so that people who are interested are free to look at these later.
Great.
Thank you. That's all I have to say for now.
Thank you, Fabrizio. Then we will switch over to Thomas.
Yeah, now you can hear me, and I'll see if I can show my screen. Can you see my screen now?
The screen, yeah,
Yes.
But we can't see the presentation yet.
Okay, so it's the wrong one. So now it's the presentation, right?
Right, yeah.
Okay. Sorry about this. Yes. Okay. Kitemill is a Norwegian-based company. We were founded back in 2008, similar to Ampex. We now have 10 employees. Maybe you can see this one also. 10 employees, which is strongly backed up by industrial partners. Kitemill have also recently been center of a consolidation process in the Airborne wind field. We took over the assets and IP from KPS last year, the Scottish-based company, and eKite this year. So I will come back to more about kite mill afterwards. Let's see here. So we also working with the ground-based generator, the pumping concept. In difference from Ampyx, we are using a vertical start and landing system. So we use propellers to take off from the ground. So we can take off in zero wind and fly up to the suitable wind conditions and produce there. Of course, the advantages is very well covered by Christian, but we are lining up the forces in a much smarter way, handling the same power with less than 10% of the material and reaching up to these more beneficial resources higher up. That gives us a higher availability, means a higher capacity factor as we access better wind resources. And of course, reducing 90% of the material gives a very beneficial levelized cost of energy. So as Christian presented, this means that, and also from Ampyx, it means that we will reach cost or grid parity at some point, but it also means that this barrier that we need to overcome to come there will be much smaller than what we have seen previous in the history. And during this period, we will benefit of having systems that can be much more mobile. They can be relocated during its lifespan. And of course, we can access better wind resources, which will make a larger geographical area viable for wind power, which is very important in the transition to the net zero society. And during this maturing phase, we believe that the weak grid off-grid market will be an important market to address with the mobility and the access to wind resources higher up. We will have some key value propositions that I think is especially suitable to replace diesel consumption. But we are also looking into utility scale niches, markets that will measure airborne wind in a different way than pure grid interface levelized cost of energy. One we see is the repowering of offshore wind turbines, can continue using the foundation and increase the lifespan of those. That could be a nice way both to give the operator an avoided cost, but also to start the maturing of airborne wind in offshore environment. And we also see, as you see on the picture here, the combination with conventional wind power, but this also goes to solar. A lot of the OEMs are offering hybrid solutions now, and by integrating airborne wind, it can give several benefits and also allow us to entering into utility scale volumes earlier than what otherwise would be possible. So, but the challenge we see with airborne wind is that these kind of utility scale projects, maybe like the Hornsrev one in Denmark, consisting of 80 turbines, will require a substantial amount of operational experience upfront for us to be qualified, and we need to build up this by and we do this by building up a pipeline of smaller projects and pipeline projects that we can fund, so we get that operational experience. Of course, to end up with a distributed fleet of a rather immature technology can be challenging. So we are also working in parallel with a fast track, and for a policy recommendation, this would be our advice also for the society to make it possible to mature a rather large portion of airborne wind plants in a specific limited geographical location. So at the present moment, we have a really good test site in Lista with a very large operational volume. This is in proximity to our workshop area where we're developing R&D tools to verify and make the technology ready. This site is already permitted to extend the number of units to 5 units from the one you can see in the middle of the picture here. So this is something we're working with this year. So this is some of the last things that are happening for Kite Mill. There is a lot of things going on these days. And to give you a sort of insight in our development, we are extending our operational envelope. We are operating not in the rain, but in between the rain clouds, but our systems start to become more and more robust to handle different kind of environment. We are
Thomas,
working.
can you also come to the end slowly, please?
Yeah, I'm almost at the end now, so that's fine. So and we see higher wing load. We have longer endurance flights. We have the only LiDAR that can measure up to 1,000 meter altitude. So this one is located next to a workshop. So it's good to have also reference from the wind speed. And our flights increase in length, and we create very nice plots. So and to summarize Airborne Wind, I just want to say we are suitable for large-scale deployment with a very material efficient technology, and of course less intermittent will be very important in the future of a net zero society. So and the space efficiency is a key factor. I think we can handle the same energy from 1/4 to a quarter of the space of conventional wind. Okay, that's all I have for today. Thank you.
Great, thank you very much, Thomas. And then we have Tobias from Sky Sales.
Hello, everybody. Good afternoon.
Hi, Tobias. Yeah, you can see the slide.
Am I sharing the right screen with my presentation?
Yeah, looks good.
Okay. Well, first of all, thank you very much for everybody's participation. And also thank you very much to my colleagues from the airborne wind industry for providing the update on where they are. To me, it is important to maybe first spend a few minutes on why we are doing this. I'm sure you are all following the political development and the decisions that our politicians have taken in respect to emission reduction and in respect to fighting global warming. And when we look at the very ambitious targets that we have given ourselves, we will very easily understand that with today's technology, there is no way we can achieve those targets, because there simply is not enough space to install all the solar panels and to install all the wind turbines that are needed to meet the world's electricity demand. And that is precisely why there is a critical demand for additional technologies. And those might be generating electricity from waves, but it is just as much a technology that allows to use the energy from high winds, from airborne wind. And therefore, we are sure that we will be able to contribute and to support the urgently needed energy transition with our systems. Now, what we have seen so far is that there are different technologies available, and the technology that we have chosen is one of them. Now, as Sky Sales, we might be one step ahead in terms that we already have a product in serial production that we are taking to the market. So we have left the R&D stage and we are in commercialization phase. We have given ourselves a very ambitious objective in respect to what we want to achieve. And what we are trying to do is to sell the present and not to sell a potential future. That is, we want to use the technology that we have available today at the level of maturity that it has today and take it to the market. And while we do that, we want to realize commercially viable projects. Now, we are beyond the test phase. We are now selling and installing systems that generate profit for us as the manufacturer and for the owner and operator. So this is an economic product. We realize, and this is what I tried to explain in the beginning, that the demand is gigantic. But the demand for electricity is gigantic, and there is room for many, many different technologies. And we do not consider ourselves in competition with photovoltaics or in competition with wind turbines or in competition with other airborne wind technologies. We believe we are one important piece of the puzzle that is required for the energy transition. So all technologies have their benefits and strengths, and depending on the application, sometimes one is better than the other, and sometimes the other is better than the one. As we have seen before, a technology at our level of maturity is not competitive in comparison with conventional fossil fuels or with wind turbines in some respect. So we have to enter the market step by step, and what we do and what markets we address, and we've seen that before, heavily depends on the local cost of electricity. And our strategy and approach is pretty much the same that we have seen before. The most important markets for us to target with today's technology are off-grid installations, remote islands, and all the many places where energy is generated from diesel mostly. That's what we can do right now, and this is where we have sold our first few systems. The next step that we are going to take, and that has already started, is to supply companies with electricity for their self-consumption, because our LCOE has reached a state where we can compete with the cost of electricity in most of the developed countries, and by doing so help companies reduce their cost of electricity. The next step, and that is something where we are looking more in the future than in the present, is commercial energy production. That is supplying utilities with our systems or IPPs. But the general concept there is to produce electricity with the objective of selling it at a profit. And we all know that in Central Europe, the feed-in prices for electricity are very, very low. The price for the consumer probably isn't, but if you produce electricity and sell it, you're looking at rates of a few cents per kilowatt hour, and our technology simply is not there yet. But as I said, we're taking it step by step. All of these three segments are easy.
Tobias, also, can you, I don't know, 1-2 minutes, please?
No problem. All these market segments are easily big enough for all the players that have a technology available. And here is a figure from the World Bank. The cost of diesel that is used to produce electricity is something between $30 and $50 billion a year. So there is so much money in that market that the development of our technology is only a matter of time, but clearly not a question if. I'm going to skip the others because they are more towards the future. And maybe finish up with a statement that is really close to my heart. If we are serious about the energy transition, we will need all the technologies that mankind can come up with. And airborne wind clearly is one of those energy sources, and systems to harvest energy from high altitude winds is one part of the solution that we all need. So thank you very much. And I hope we will make the world more beautiful. We're going to reduce emissions, and we're going to have many, many kites all over the place. Thank you.
Great. Thank you very much, Tobias. Now we switch over to my presentation again. So you should see, hopefully now, my slides. So yeah, just a few more slides before we enter the Q&A and discussion. We wanted to show you the opportunities for the airspace industry, and we heard already some numbers from Fabrizio. They may not add up completely, but the order of magnitude is the same. So we have looked into the Boeing market forecast, and for the next 20 years, they plan some 43,000 deliveries, or that's what they say, what's the market demand is. So about 2,000 planes per year. Now, if we look into these global scenarios of wind that were mentioned by Tobias also, there are some between 3,000 and 10,000 gigawatt of wind required by 2050. So these are, it's a large range, but yeah, we don't really know what the share of wind will be. But assuming that we would get for the airborne wind sector just 5 or 15% of that, that means system sizes of 5 megawatt, that would mean about 100,000 systems in 20 years. And that makes about 5,000 airborne wind energy systems per year. So we think there will be a market larger than the plane or the aviation industry market, with definitely not as much material, but the wingspans of these devices may also well reach 40, 50 or 60 meters. So just to give you an idea that this is not something a niche by that time anymore, but or not by that time over the next years, but that this can really grow big within your industry. And there are a lot of opportunities, we think, for the supply chain, including aviation, aeronautics, also automotive, chips, IT, tether, ropes, mechanical engineering. So there are a lot of parts and knowledge that we need from different industries, and yours will be an important one. And you have seen parts of the systems already before, but there are these control units, the tether, the ground station. Here you see this launching platform from MPIX. So a multitude of systems that need to be developed, and where your knowledge would also be quite useful. And just to finalize now, one way to collaborate would be through a so-called task of the International Energy Technology Collaboration Program on wind. So there is, you may have heard about the International Energy Agency that also creates scenarios for the future world energy outlook. And within that framework, there's a technology collaboration program on wind and also other technologies. But within this framework, there are so-called tasks, and we now got a new task, this new task 48 on airborne wind energy, which will start by the end of the year. And we are currently in the setup phase. So here we want to work on these topics: wind resources, reference models, tools, metrics, safety and regulation, social acceptance, and airborne wind energy architectures. And I highlighted here a little bit what could be interesting for the airspace industry: definition of metrics, reference models, tools, airspace integration concepts, safety, circular economy, life cycle analysis. So a lot of things that some of you may already deal with, and where we think that would be useful to work together. So as I said, we think these are here topics where we would really like to work with you. The IAA Wind task could provide a way to structure this collaboration. There are other ways too, and also direct ones, but that could be a possibility. And please let us know if you would be interested in that, and we give you a little bit more feedback. Shouldn't be too, it's a process that we are setting up now, and would be quite easy to join. And with that, I basically look forward to our collaboration. You find our contacts here in the slides that we will share, and also from our interventioners. And now I would like to open the floor for any questions or comments that you may have. Thanks very much.
Thank you. Thank you for all these interesting and exciting presentation. So you can ask the question using the question tool, or if you want, you can switch on your micro if you want to speak with the speakers.
Only for some reason I don't see anybody at the moment. I just have this. Is this normal, or do you see me and the others?
Yes, we can see you and the other speaker.
Okay, I am unfortunately, I don't see anybody. Anyways, yeah.
There's a first question, if we can share the slides. So from our side, the answer is yes.
Sure.
Yes, if you agree, we could share the slides with all the attendees.
Yeah, sure. We will send them to you, and then.
Okay, slides and contact also.
Mm-hmm.
Donc, pas
if you want to
question,
ask a question in French, then please go ahead. We try to
we
answer.
will translate. Yes. Donc, si vous avez des questions, des commentaires aussi, ou nous faire part de vos premières impressions et comment vous vous projetez dans une potentielle collaboration. Voilà, l'idée était vraiment de vous présenter cette filière et d'ensuite voir si on va plus loin dans l'organisation de groupes thématiques, de mise en relation, de groupes de travail, etc. Donc voilà, n'hésitez pas. Alors, nous avons une question. We have a question. How do you convert the mechanical energy in electrical energy? It's a question for all the companies.
Well, I can take this over. So basically, you have this tether, the rope that goes around a drum, so a big cylinder. And once you pull it, the cylinder turns, and then you just put a generator on the same axis, and then the generator produces the electricity. So you always have this, once the kite pulls the tether, the drum turns, the generator produces electricity, and then there is this short moment where the kite has to fly back again in these pumping cycle modes that we have seen, where the drum has to turn around and wind in the tether again, where you need some electricity. But yeah, then the cycle starts again and you produce electricity.
I have one question. What are the sites for the experimentation? Do you have identified some place to do this experimentation?
Are you asking about sites or locations?
Location.
Yeah. So this is of course not easy to find locations, but there are several locations approved for airborne wind now, and this location will allow us to bring the technology for the next scale and for the next step, I would say.
Okay.
So one thing I can add is this with permits and so. For this stage, we are still building up the data for consequence analysis and so. So most of the permits will be temporary until we have a few years of operational experience.
Okay. So
if I may answer this on behalf of SkySails, we are currently pursuing more than 100 different projects in various countries and locations. In the projecting phase, we also need to go through the local approval process for the airspace use, but also for the integration into a local grid or the grid connection. So it is a lengthy process that we have to go through in every individual country. But we assume that it only needs to be done once to set a standard, which is why it is so valuable that many companies are working on the same thing, because one technology will automatically benefit from the other, because in the end, the requirements that we have are very similar. Coming to France, we are pursuing a number of projects in France. The one that Christian mentioned in the very beginning, our current project on Mauritius, to some extent falls under French legislation, so we might have some spillover effects there. It is a challenge, but we are extremely confident that one by one we will get the approvals that we need.
Okay.
If I can say a few words regarding AMPIC. So we are in the process of obtaining permit to fly from the European Aviation Safety Agency for our first prototype. And as we develop our commercial product, we aim to obtain certification for the aircraft design. That means that once we have this certification, it's a little bit like when Boeing sells an airplane. Once the plane has been certified, they don't need to obtain a certification for every single plane. That would facilitate the local process of permitting, where basically you need to have a construction permit, you need to obtain a dedicated space for flying your aircraft, but the aircraft is already certified. So that's the strategy we're following. So we're developing a site in Ireland together with the RWE, and we also have a number of other sites that have been identified, discussions with some local utilities for our first commercial program.
Okay, thank you. We have many questions. So will you shortly need external support to industrialize all large-scale production on your systems?
So maybe I can answer that. So yes, we are setting up a strategic collaboration with some key supplier, both to the suppliers to the airspace industry and to other industries. We are dividing our system into components. So for example, manufacturing of the wing, manufacturing of the actuators, the propulsion systems, the landing gear. So all of these will ultimately be contracted out. Certainly the manufacturing, most probably also the detailed design, and AMPIC's power will be focused on the architecture and the conceptual design, and of course in assembly, integration, and commercialization. Regarding the launch and land platform, the power generation apparatus, including the winch and the motors and so on, we're also working with existing established players. So that will facilitate the ramping up manufacturing once the product has been fully developed. So we're very excited about the opportunity to be speaking here, and hopefully what we've presented will encourage some of the participants in the audience to reach out to us and initiate discussions about potential technological partnership.
Thank you. Tobias or Thomas, you want to say something about this question or not?
I can just briefly add that also we hope that the aim to secure industrial leadership will release some incentives in some regions. So that would be beneficial to accelerate the development of the value chains and the technology.
If I may add, there's a very, I would say, critical and unique incentive for players in the aerospace industry to attempt a collaboration with the airborne wind energy system, is that it gives you the opportunity to test some innovative materials, test some innovative manufacturing processes that you may find difficult to sell to your existing clients, because the aerospace industry is very conservative, very focused on safety, and it's sometimes difficult to push some innovation into the market. So we've attracted a lot of interest from some key suppliers to the aerospace industry, because they saw the opportunity with Ampix Power and with airborne wind energy in general to test some innovative materials. So of course we are very focused on safety, but we're not flying 300 people in an aircraft. It's basically a drone, and we are very focused on cost reduction, aerodynamic efficiency, and so our priorities are slightly different, and we are more open to innovation and taking some measured risks in order to test some new materials and test some new manufacturing methods that can significantly reduce cost and weight of the aircraft. And once you've demonstrated that these new innovations that you've developed actually work on a large scale with hundreds of units in operation around the world, you will be in a very good position to sell this technology to your established aerospace clients. So I think this is a very specific incentive for some of the suppliers to the aerospace industry to take airborne wind energy seriously. Not only because it's potentially a very big market, as Christian said, but also because it would allow you to push some innovative technologies into the market and test it. Also, it of course provides diversification in a market that may have different cycles than airspace, than aviation.
Maybe if I can add here one thing, because Fabrizio mentioned drones, and he mentioned also that they are in the process with the EASA for a certified system. Other suppliers actually, or also in other discussions, we think that the specific category for another drone regulation would be sufficient for many of the systems. So that widens and simplifies with the process of producing basically and getting the systems into the market. And there are even discussions for certain systems to be rather seen as obstacles, and that may even changes again the view on safety issues and so on. So this is not fully decided in which direction we will go, but just that you understand that there are still open points to be discussed with regards to these safety issues and the classification of our systems. Thanks.
Okay, another question. Are you planning to team up with partner companies for green hydrogen production?
If I may answer for SkySails, yes, we are. Because we understand that green hydrogen will play a major role in the energy transition, and green hydrogen is an excellent means of storing excess electricity that at one point will always be a a byproduct of renewable energy production. It is a technology that we believe nicely connects with airborne wind energy systems, and it's only a matter of time until one of the people in this webinar will have the first hydrogen installation somewhere.
Mm-hmm.
Yeah, I agree. I mean, for large-scale development of hydrogen, you need abundant and cheap electricity, and that's what we want to provide to the planning system. Yeah, we believe we. I mean, we've said about a lot of the benefits of airborne wind energy. Of course, lower cost is one, but the ability for us to deploy on a very large scale offshore with a much reduced environmental footprint, it really increases by an order of magnitude the potential availability of low-cost, clean electricity. I think the potential for very large-scale deployment offshores is one of it's kind of the holy grail for airborne wind in the long term.
Yeah, and then I will add that I believe hydrogen is a very important part of the picture, and we need it. But I think airborne wind itself will be a more important technology in the net zero society. But yeah, we will see combinations of those.
Okay. Next question: what are the specific electrical components you are looking for? Power requirements for demo?
I think very generically speaking, we all use some sort of generator and electrical engines. We all use steering electronics. I'm not sure what the correct term is in English, Steuerungselektronik. And I believe that apart from the aerodynamic part, from the flying part, we all rely on industry standards as much as we can to use the already existing economies of scale when it comes to the cost of those components. But I believe it is, for me, it would be very difficult to be more specific than that.
Yeah, as the only one of the companies using the VTOL system, I can say that we are also depending on the drivetrain for the vertical takeoff and landing, and we benefit from the same type of technology you use for drones and air taxis now. And I don't think that we need to wait for them, but we will be a part of the applications that will enable more and better power electronic and drivetrains to propel aircrafts in the future.
Yeah, if I may add to that, so I think airborne wind energy is so novel and so technologically challenging that we are actually at the forefront of what technology can do in many different areas, not just aerodynamic efficiency, but also if you look at, I mean, I could name maybe 20 different systems or subsystems in our technology where our requirements are unique and much more demanding than anything else that is available in the market. So we need to do a customized development for many components, which makes it more difficult and more expensive when you're building your first prototypes. But we see that it can really deliver a lot of benefits in the long term. If you talk about the drivetrain, we're looking in parallel at electric drivetrain, hydraulic drivetrain, and mechanical drivetrain. Both have different benefits, and some are more suitable at a smaller scale, below 1 megawatt. Some are more suitable at a larger scale, above 1 megawatt. But the requirements of airborne wind energy for this type of dry trains are also quite unique in terms of speed, in terms of power. So for some technology providers, yeah, airborne wind energy is a unique opportunity to deploy the technology in an operating envelope that no other industrial segment requires. So there's a lot of innovation in various aspects of in various subsystems that airborne wind energy utilizes. The feathers, the winch, the motors, the propulsion systems. There's a lot of unique technical specifications that we are looking at.
Okay, next question. Can you explain how a tethered drone can create more energy than a wind turbine, sorry, when the wind catchment seems to be lower on the drone?
Yeah, well, when you do a large circle, you don't capture only the energy of the wind that is actually the wings area of the plane, but the whole area that you're flying around. So
maybe another point is that the systems we have seen are still comparably small to what we foresee for the 5 or the 2, 3, 5 megawatt range of systems. They will become bigger. The ones that you have seen are now 150, 200 kilowatts. So that's 1/10 basically of the conventional wind turbines. But yeah, the conventional wind turbine, the most energy is generated in the tips, and this is basically where our systems would fly, and they will fly higher where the wind speed is higher. So that will also add another component in there.
Well, from my perspective, the most important point is that our airborne wind energy systems can be used in places where a wind turbine cannot be built at all or is going to generate zero electricity. So I don't think it makes much sense to compare our technology against a wind turbine, because they clearly have their strengths and they clearly have their benefits. But there are thousands of locations where nobody would ever build a wind turbine that is perfectly suitable for an airborne wind energy system. So it is not a question who's better, but the question should be who is producing more electricity in a specific location.
If the question, then question was how we can produce more energy. I think that was a statement I have, and that's the conventional wind turbine is spread over the two-dimensional plane. So the wind will hit the first one first, and that will create the wake effect that will prevent how close you can put the next one. So they will never exceed 5 megawatt each square kilometer is what I found. Larger turbine need greater distance, while we are operating in a three-dimensional volume, so we can arrange the production and we can put the plants much closer to each other. So since we are also operating in different heights, and that allows a higher power density, which I think will be very, very important if you see the net zero society and the volumes that we need to build of wind power to reach these ambitions.
Christian, can I present just a couple of slides to answer that question with numbers? Maybe that would be a good way to answer the question.
Okay, I'm going to give you the roar. It's okay.
Can you see these charts?
Yes.
So we've made a benchmark of our technology versus traditional airborne, traditional wind, which we call horizontal axis wind turbine, and against solar. And there's a lot of different KPIs that you can look at. But one KPI is how much energy, how many megawatt hour are you producing per year for 1 square meter of active surface? So for the airborne wind, active surface is the wing area of our aircraft. For the kite, it's the area of the kite. For the wind turbine, it's the area of the blade. And for the solar panel, it's the surface of the panel. So I mean, of course, we are in the very early stages. So our current system is AP3. It's a small scale system. It's not yet fully optimized, but when we are looking at in the long term, we expect for 8 megawatt system to have about 133 megawatt per square meter, which is about 50% more than traditional wind. Part of the reason is that the center part of the blade is moving at a very low speed, so it's not producing a lot of power. So a lot of that surface area is not used. And of course, compared to solar, the energy density is like much higher. Compared to kite, it's about 10 times more aerodynamically efficient, so you can have a smaller surface area for the same power, but of course, it's more expensive to build a plane than to build a kite, so the two compensates. If you look at how much power you can install per square kilometer, then we have a big advantage compared to traditional wind, as Thomas mentioned, because we can put our systems closer to each other. And of course, since we have a higher capacity factor than solar, when you look at the amount of energy that can be produced per square kilometer, it's about 5 or 6 times more than wind, and about 3 to 6 times more than solar. The difference between airborne wind and solar is that to collect the electricity from 1 square kilometer, you need to cover the whole area with solar panels. And we only occupy 3% of that area. So when you look at the amount of energy produced per square meter of land actually used by our facilities, we're about 1,000 times more efficient than solar. Of course, the footprint of a windmill is extremely small if you just look at the tower. And let's say you put a 10-meter radius around the tower. So traditional airborne wind has a very small footprint. That's undeniable. If we go offshore, it's a different story because they need a very big floater, and we will need a much smaller floater. So we have a better energy density there. But compared to solar power, then the difference is like 3 orders of magnitude better. Of course, this is a benchmark that we've done ourselves. We would love to collaborate with the other airborne wind energy companies and with solar and traditional wind companies to do this benchmark together. Maybe Airborne Wind Energy Europe can help us do that, so that we have a reliable source of comparison.
Okay, we have 4 last questions. Next one is someone who would like to understand if any of the companies, any of you, is thinking about a mobile ground base for the systems. This way, a lower relative velocity for the wind will be required, and consequently, the performance maximized.
I'm sorry, I did not understand the question. Can you repeat?
Me neither. The first part, especially.
Yes, sorry. If you are thinking about a mobile ground base for the systems.
A mobile ground.
Yeah, so the airborne wind energy systems that we use, at least the small ones, are easy to install and to transport. I wouldn't really say it's mobile, but it's certainly redeployable.
Mm-hmm.
That I think is pretty clear. I don't know what the second part of the question is and how it's related to the first.
But the first part there is quite important. When we're looking in the big transition we need to make, there will be a lot of waiting time for permits and for grid improvement of the grid, and there, I think there will be a huge need for temporary capacity that can be relocated during its lifespan without sort of losing the assets. And I think maybe Airborne Wind can play a very important role in this transition by being the technology.
Yes, I agree. I mean, I spent many years working in Africa, and what you often see is that just a few months before an election, the president signs a contract with Agreco to install a lot of diesel generator to alleviate the power shortcuts. And they do that without any planning, any authorizations, like quick. And then after the election, they just take it away. So we can do that. We can provide a 6 months leasing contract, either for emergency relief or for some temporary usage, and then redeploy it. That's a very unique business model than that Airborne Wind can provide compared to traditional wind or solar, for example. And diesel is already using this business model, either pay-per-use or lease contracts.
Okay, next question. Was there some research project to combine windmill with stabilized zeppelin retained by cable to the ground in order to catch wind at higher altitude?
Yeah, I can answer that. There is no research project, but the whole idea is to create something that is better or have advantages, like Tobias said, to wind turbines. And I think we have very good indications on that. So I guess that's the answer.
I mean, it makes sense to hybridize airborne wind with solar, but not with wind, because then you have these masts all over the place that could interfere with the feather. But it would be very beneficial to hybridize solar with airborne wind, because our footprint is very small, so we can put our platforms in between the panels, and the panels are very low, so they don't present an obstacle for the aircraft. And our aircraft flies very high, so it basically does not generate any shadow on the solar plant. So hybridization between solar and airborne wind makes a lot of sense.
And then I would like to add that it's also possible to integrate with conventional wind turbines, but it's more challenging, that's true. But it will allow the customers to reach higher up and also extract the resources that only we can access from the same area.
Okay, and the last question, is VTOL an option?
Sorry, what is an option?
Vertical takeoff and landing. VTOL.
Yes, VTOL, sorry.
That one I have to answer, because we are using VTOL, and that's certainly an option. So we are doing it, and we are producing energy with after taking off vertically. So yes, the answer is yes.
And there are 2, 3, or 4 other providers that also foresee that for their systems.
Okay, it was my last question. I don't know if there is other question, but je ne sais pas si vous avez d'autres questions, si on a répondu aux questions que vous aviez posées. N'hésitez pas, on a encore quelques minutes. Je crois qu'on a quand même déjà pas mal travaillé le sujet là sur les quelques questions qui ont été posées. Okay, if there is no more question, I want to thank all the speakers for this presentation, for the discussion also. It was very, very, very interesting. And I hope that this will pave the way for future collaborations. We remain at your disposal for further information and to go further in the collaboration between Airborne Wind Energy and Aerospace Valley partner. Thank you.
Okay. Thank you for organizing this call, for the invitation.
You're welcome.
Indeed. Thank you very much, Emily and Julien and Thilo, for organizing this. We very much appreciate that opportunity. And yeah, we hope that wasn't the last time, and we hope to hear from you. Whatever questions you have, please send us an email. We will get the presentations through Emily, and then yeah, we hope to be in contact. Thank you very much.
Okay.
Thank you very much.
Thank you.
Perfect.
Thank you.
Bye.
Bye-bye.
Bye-bye.